Today we're going to be talking about solving quadratic equations using the zero product property. And the zero product property is really just a fancy way of saying if I have something times something else is zero, then at least one of those two somethings has to be zero. If I say 7 times the number is 0, you know that number is 0. And why is that helpful? Well, if we have things factored, then we know that that's really just a something times something is 0, and then I can separately set each of those two somethings equal to 0, and I will have solved the quadratic equation. So in particular, if I know my quadratic factors into x minus 5 times x plus 2, the original equation being what would happen when you FOIL that out, so that would be x squared minus 5x plus 2x is minus 3x minus 10. Was really your initial equation being set equal to 0. Take that, factor that guy, and then once you've done that, you can say, okay, that means either x minus 5 is 0, so x would have to be 5 when you add 5 to both sides, or x plus 2 is 0, so x would have to be negative 2 when you add to both sides. So my final answers would be that x can equal negative 2 or 5. When you have quadratic equations like this, you may have up to 2 answers. In fact, most of the time you'll have 2 answers. Occasionally you may have no answers or just one answer. The one answer occurring whenever it factors into basically something squared, like a single something squared like that, equaling 0. That would be one answer, or it could be no answers. If you end up with something like x squared plus 50, add 50 to the other side, and oh my gosh, nothing squared is going to get you negative 50. We'll be coming across those exceptions to the rule later on in future videos. Here we're actually just dealing with where he is actually factorable, and when he's factorable, you're going to be setting both of those guys equal to 0 and solving. So let's take a look at another example. So in this next example, that initially would have been negative 10x squared minus 80x that you would have correctly factored by pulling out a greatest common factor of negative 10x. Now you can go ahead and just set each of these equal to 0. So either negative 10x is 0 or x plus 8 is 0. Negative 10x is 0, divide both sides by negative 10. You get x would be 0 itself. X plus 8 is 0, subtract 8 from both sides. You get x is negative 8, and those would be your 2 answers. So if you notice, in order to factor this, what you have to do no matter what is first rearrange the initial equation so that it's set equal to 0. So if, for example, on the previous one, you had initially had negative 10x squared equals 80x, you would have needed to subtract the 80x from both sides in order to rearrange this guy so that he's actually set equal to 0 first. Then you want to factor the expression. If he's not factorable, you need a different technique, which would be in other videos, either by using the square root property, completing the square, or quadratic equation. The quadratic equation will work for absolutely everything. But if he's factorable, you want to just factor him because this is much faster than those other methods we just mentioned. Then you use the zero product property. You solve each of the now linear equations. And then you also can check your work at the end by resubstituting it into the original. So if I plugged 0 into the original, for example, I'd have 0 minus 0 is 0. Great. If I plugged negative 8 into the original, I would also find that I would have a 0 minus 0 situation, so I would be good to go. So let's check this next equation. So this next one is a case where the leading coefficient's not 1, so I need to figure out what's going to multiply to a times c and add to b. A times c in this case is negative 2, b is negative 1. The numbers that would multiply negative 2 but add to negative 1 would be negative 2 and positive 1. So I will split the middle term into those two terms, drop down everything else. I should have also technically double checked that this was set equal to 0 at the beginning, but he already was. Then I want to factor out the greatest common factor of each group. This first group has a greatest common factor of 2x, so I'm going to pull out 2x. 2x squared divided by 2x leaves us with x. Negative 2x divided by 2x leaves us with negative 1. The next one has no non-trivial greatest common factor, so its greatest common factor is simply 1. Then they have x minus 1 in common, and when I factor out x minus 1 from both terms, I'll be left with what's different, which is 2x plus 1. When I was just factoring, I would have stopped there. Now I can actually find my two solutions. So I either have the x minus 1 is 0 or 2x plus 1 is 0. For x minus 1 is 0, I would add 1 to both sides. I would get x is positive 1. For 2x plus 1 is 0, I would first subtract 1 from both sides and then divide by 2. So I would have two solutions. One is x is positive 1 and the other one is x is negative 1/2. Go ahead and pause your video and try these next three problems on your own. So here, for the first one, this is already pre-factored, so don't overcomplicate your life. That means that you want to set each of these guys equal to 0. This you want to also set equal to 0 and then solve for t. For the first one, I would subtract 1 from both sides, then divide by 2. I would get t is negative 1/2. For the second one, I would subtract 4 from both sides and then divide by 3. I would get t is negative 4/3. For this next one, keep in mind that is the same thing as 3x plus 2 times another 3x plus 2 equaling 0. So technically I could set them both separately equal to 0, but they're the same equation, so they're going to give me the same answer. So I really just need to set one of them equal to 0, subtract 2 from both sides, and then divide by 3. So this is a case where I only ended up with one solution because he factored into the same linear term being repeated, so I was good. For this next one, he is not yet factored and not yet equal to 0, so I'm going to have to rearrange him to be set equal to 0. And I'm used to seeing the x term remain positive, the x squared term remain positive, so I'm in particular, in this case, going to end up moving everybody to the left-hand side. So I get x squared plus 5x minus 84 is equal to 0. Now I need to figure out what's going to multiply to 84 and add to 5. So 84 is actually not something that I think about that often off the top of my head, so I'm going to kind of just brainstorm some factors here to the side. So I know 1 and 84 are going to go in with different combinations of plus and minus. In particular, since I know I want to add to a positive number, I'm going to make the smaller number in terms of absolute value my negative one, and that one doesn't appear to add to 5. I also know that 2 has to go into 84, so if I do 84 divided by 2, that will give me negative 2 and 42. That's again not going to add to 5. And 42 is still divisible by 2, so I'm thinking that 4 probably goes into 84, so I can have negative 4, and 21 would also give me 84, but again that doesn't add to 5. So I'm thinking that it looks like maybe 6 goes into 84. I could do negative 6 and 14. That's getting closer, but we're not quite there, so I'm going to go ahead and try 7. It looks like negative 7 and 12 is our winner because negative 7 plus 12 does indeed give us 5. So sometimes you have to educatedly guess and check to the side. And here, because that leading coefficient is actually 1, I don't need to do my formal factoring by grouping. I know that he will go ahead and factor into x minus 7, x plus 12 equaling 0. And the reason why I did that is I can now separately set each parenthesis equal to 0, because if I have something times something is 0, at least one of those two somethings has to be 0. So I get x is positive 7 and x is negative 12, and both of those are my final beautiful answer. Now the next one may look tempting to call pre-factored, but as you notice, he's not actually set equal to 0, so we do actually have to expand him out, rearrange him, and then factor. So if I were to expand him out, I would get x times x is x squared, x times negative 3 is negative 3x. We have equaling 3x in this case. Then I have to rearrange him so he's set equal to 0, so I'm going to subtract 3x from both sides. Then I get x squared minus 6x is 0. In this case, we have a greatest common factor of x, and then I'd still have x minus 6 left in parentheses. Now I can separately set each factor equal to 0, so I get that either x is 0 or x minus 6 is 0. For x minus 6 is 0, I'm going to add 6 to both sides to get x is positive 6. So my final answer would be that x is equal to 0 and x is equal to 6. And if you were to plug that into the original, you would end up finding that that's true, because if I plug in 0, I end up with 0 equals 0. If I plug in 6, I end up with 18 equals 18, so I'm good to go. Go ahead and pause your video and try these next two yourself. So for this first one, this looks like it's got to be factored again. So 2z times 5z is going to get us 10z squared. 2z times 1 will give us plus 2z. And then drop down the 5z, drop down the 1. I'm going to subtract 5z and subtract 1 from both sides. So then I end up with 10z squared minus 3z minus 1 is equal to 0. Now this is a case where my leading coefficient is not 1, so I've got to use the AC method. So a times c in this case is negative 10. b in this case is negative 3, so I want to multiply a negative 10 and add to negative 3. That in particular will be negative 5 and positive 2. So I'm going to break down that middle term into negative 5 and positive 2. Drop down everything else. Now I'm going to go ahead and start my factoring by grouping process. The first two terms, their greatest common factor is 5z. 10z squared divided by 5z will leave me with 2z. Negative 5z divided by 5z leaves us with negative 1. And the next two terms, there's no non-trivial greatest common factor, so their greatest common factor simply is 1. Now I'm going to go ahead and technically factor out what they have the same, which is that parenthesis of 2z minus 1. And then when I factor that out, I'll be left with 5z in the first term and then plus 1 in the second term, equaling 0. Now I'm ready to set up my two mini equations. So either 2z minus 1 is 0, or 5z plus 1 is 0, because if I have something times something is 0, one of those two somethings has to be 0. Then both of these are two-step equations, so I either get that z is equal to positive 1/2 when I undo the subtraction, then undo the multiplication, or I get that z is equal to negative 1/5 by subtracting 1 and then dividing by 5 to similarly get rid of that addition subtraction first and then that multiplication division. And those would be my final two beautiful answers. Of course, if you have things that don't require the AC method, don't overcomplicate your life. Here we have a leading coefficient of 1, so we can directly ask what's going to multiply negative 9 and add to 8. In this case, that would be positive 9 and negative 1. And then we separately set each parenthesis equal to 0, so either x plus 9 is 0 or x minus 1 is 0. So either x is equal to negative 9 or x is equal to positive 1 is both of our final beautiful answers. For this next one, recall he's actually not set up how we want yet though, because we need to make sure that that we have this equal to 0. Otherwise you can't exploit the zero product property because you're trying to find out something times something is 0. So we end up with x squared minus 2x minus 15 is now equal to 0. Now we're good to go, and that leading coefficient is 1, so I can jump to my parentheses. In this case I want to multiply c and add to b, so multiply negative 15 and add to negative 2. That would be negative 5 and positive 3. And then when I set both of these equal to 0, I end up with x is positive 5 and x is negative 3 as our final beautiful answers. So this technique only works if it is factorable. If you try to do what multiplies to a times c and adds to b and nothing works, or if the leading coefficient is 1 and you're trying to multiply c and add to b, and it doesn't work, that means you cannot factor by grouping. But when you can factor by grouping, it is a nice way to go ahead and just use those factoring skills, and that you just want to first rearrange it so that it's set equal to 0, then factor, set each expression equal to 0, that's exploiting that zero product property, solve your remaining linear equations, and then it's usually good practice to also go ahead and plug those solutions back into the original to make sure that you get what you expect.